am excited to bring on our next hosts and experts. We have Philip Carter and Christoph Kleziak. Kleziak, how do I say your last name? I mispronounced that.
It's actually Czeslak.
Czeslak. Okay.
Yeah.
I wouldn't have been able to
no one will be able to do that, so no worries. Thanks for having us.
Yeah.
Yes, of course. Thanks for being on the show. It's great to have you, Philip. It's amazing to see you again.
Indeed.
We will. Y'all are talking to us about a tour of F#, the editing tooling, correct? Yes.
That would be correct.
Amazing.
Yes, that is correct. So I'll begin with sharing a little bit of slides, and then we'll do some brief introductions, and then it'll just be demo time, really, because this is about editor tooling, and editor tooling is best when you show it and when you use it rather than just talking about it. So
couldn't agree more. I'll let you take it away.
Yes. Hello. My name is Philip Carter. I'm joined by my good friend Christoph, or Chris, as he sometimes goes by. We have both been doing a lot of F# for quite a few years. I used to work at Microsoft actually on F# for a little over 5 years, and now I do developer experience over at Honeycomb. Quick plug, if you're interested in observability tooling, you should check out Honeycomb. It really does offer the best way to look into your distributed systems and all that other stuff.
Totally, it looks amazing. So yeah, my name's Chris. It's actually funny because I think it's for both of us. It's like first public talk after the milestone. So you've left Microsoft and I kind of joined Microsoft family. So nowadays I'm a research engineer at GitHub. I was helping to build Copilot. So also quick plug, if you are interested into some AI stuff, check it out. All right, we probably should move on. Like introductions are boring.
Yeah. So really kind of the main takeaway that I want people to have here, if you're not familiar with F# or just have a little bit of passing familiarity with it, is that F# tooling is everywhere. It's absolutely everywhere. Pretty much no matter what kind of developer you are and whichever development environment you prefer, you will have something available to you, right? If you're a .NET developer or just working in a .NET shop that's been using Visual Studio forever, guess what? F# is right in there. If you're using VS Code like millions of people are today, it's right there available to you. If you're on the Mac, you can even use Visual Studio for Mac. You can use JetBrains Rider for all of these operating systems. Ionide is, although it's primarily used within Visual Studio Code, it's actually kind of a suite of tools instead of just purely editor tooling. And so it gives you some good stuff there. And then, I mean, hell, if you don't care about editor tooling, you just want like a little text editor and a command line interface that does what you want, the .NET CLI sort of has your back with all of that. And of course, it can be used in conjunction with everything else. The .NET CLI is packaged with the .NET SDK, which includes F# by default. And so anytime you install .NET, you get F#, and everywhere that .NET runs, F# runs as well. And that includes well over a dozen, I think several dozen at this point, Linux distributions, obviously Mac and Windows and that kind of stuff. So yeah, that's the main thing. It's everywhere. And so, we have limited time. We can't possibly show like every cross product of all the different stuff that you can do. So, but critically, and this is what I want Chris to briefly talk a little bit about, is this is not just a whole bunch of little separate efforts everywhere. I mean, like, yeah, there's different tooling, but really it's powered by a central component.
Yeah, so the component is called F# Compiler Service, and without going too deeply into technical details, it is a version of F# Compiler that's distributed as a normal .NET library. You can add it as a NuGet package to any of your .NET projects and get access to the internal APIs of the compiler, some additional APIs that help build editor tooling and any other kind of tooling. So this is the component that enables us all to build this ubiquitous language tooling that is really similar across all those editors and all those places. I mean, the user experience differs a bit between different IDEs and different editors, but at its core, the set of the features that are supported in all of those places is fairly similar. And I think that we will quickly move to demo time. So let me take over, and if we could switch to my screen, that would be lovely.
Yeah, let's see it.
Please let me know when we are live, Philip. Right, yeah, I think that my screen should be live.
Screen should be
Okay.
shared, and okay, there we go.
There
Cool,
we go.
you're good to go.
Okay. Yeah, perfect. So here I have open Visual Studio Code instance. It's empty folder. There is nothing in there here. So we want to start with creating actually some kind of F# project. So there is a command F# new project. I can run it, and this will deactivating extension takes a moment. Okay, yeah, that shows me a list of possible projects types I can create. This is powered by the .NET SDK. So as was mentioned before during the Isaac talk and other talks, you can install your own templates for the .NET SDK, and if the template supports F#, it will be displayed here in the list. So let me create console application. There are a couple of parameters that I may provide, but I don't need to. And then this should hopefully, yeah, this created actually simple F# project. So as you can see, it created a couple of files, but what is important, it actually enabled Ionide, which is F# extension for Visual Studio Code. You can see here, there is this additional F# icon at the activity bar on the left in Visual Studio Code, which will be display list of your project. If you would have solution, it would be displaying the list of the projects in this particular solution. It is a feature that tries to simulate the solution explorer that you know from Visual Studio or from JetBrains IDEs like Rider. So you can check list of packages references, check list of project references. Well, there are none in this case. You can right-click on the project, you can do run, you can debug, you can build, all the stuff that you know from normal IDE. You could, if there were more files in the project, you could move them up and down because that's kind of important for the F#. However, let's quickly jump to the file. And so there's a couple of things that we will see in a moment. Okay, here it is. So first of all, as we've seen in the previous talks, I'm not going to deep into basic functionalities. As we've seen in the previous talks, stuff like go to definition, autocomplete list, tooltips are all working just fine as you would expect in any other IDE, in any other programming language with decent tooling. What is really interesting in case of what we do in Ionide, the first thing that you can see is that we have those code lenses. So code lenses is the feature in Visual Studio Code where you can display some virtual information on top of some symbols. So here we display the type of our symbol, this string, arrow, string thingy, or this thing here. This is type definition of our symbols. So in F#, as was mentioned before, F# has type inference feature, which means that you don't need to specify the types. However, when you code, when you quickly read the code, it is useful to have those types visible all the time. So we provide that. And then there is the references code lens, which is known from C# tooling. When you click on that, it will display the list of all usages of given symbol. If you, let's say, let's do that. This is already updated. This works across the project files. This works across files, across different projects. I'm not going to show that. You need to trust me, but it is pretty great. Another really interesting feature that's kind of connected to that, and it's in the style of providing additional information for user when they code. Let's write some pipeline stuff. So as you may know, in F# we pretty often code in this pipelining stuff. So whoops. So you get some input, you pass it to the next function using the pipeline operator, and you do so and so and so. So what is really useful, string, I cannot type. What is really interesting?
Sorry to quickly interrupt. Could you just have the code on the upper half of the screen because okay, cool.
So what is really interesting is that we display those informations about what's the type of every step in your pipeline. This is super useful when you do bit bigger of those pipelines. For me, it was always a bit confusing about what's really going on regarding types. This helps a lot with that feature. Staying in the area of reading code, what I'm really proud of is how good are tooltips in Ionide. I know that tooltips are everywhere, and this is maybe not super exciting feature, but tooltips in Ionide are a bit more advanced than in most other IDEs. So first of all, we have those formatted function signatures. Then we display a whole bunch of additional informations in the tooltip that is usually not displayed in other tooltips. I think most IDEs are using just a summary XML tag for displaying information. We are using also other XML tags. And we are also displaying the generic parameter resolution and things like that. Related to that is a feature called info panel. So I can open that. As name suggests, it's additional panel that you can open in Visual Studio Code. It displays the documentation. Again, what is really interesting is that it is kind of like connected to your text editor. So when you navigate, when you move around code, it automatically updates. When you code, it automatically updates. But at the same time, you can also click on those things, like all those things that are marked as a link are actual links. So you can, for example, click on this function. You will go to the documentation of this function. You can click on some type. It will go to the definition of this type. And as you can see, this is like integer type. This is coming from the .NET Standard library. So it's not really connected to your code base. It works across all the references that you will have, which is pretty exciting thing. Another thing is a bit more advanced. Let me close the info panel. We don't need that anymore. Another thing that I want to show is a bit more advanced navigation that we have in Ionide. So let's imagine that you have some function from the F# core library, for example, array2d. I can F12 on that, and this will actually take me to the source code of this function. So this feature is provided and powered by the feature.NET functionality called SourceLink. Without going into details, this allows package authors to package also the source code together with the compiled versions of DLL. And if the package is source linked enabled, we detect that and we provide this like nice navigation. In case of the packages that don't provide source links, for example, .NET Standard doesn't provide source link. Don't ask me why. When you do F12 on that, we will try to decompile the code. Unfortunately, it's to C# because the most common decompilers in .NET ecosystem decompiles towards C#, so we do that. But yeah, it also works. So all that was kind of like connected to reading the code and navigation, but there is also writing the code and maybe some refactorings. So in Ionide, we have a whole bunch of quick fixes, and Isaac's shown some of them, but also I want to show a couple of them. And I think like we implement total few dozens of those, so I'm not going to show all of them, but let's go quickly through this like really short file and see what we can do. First thing interesting is this add explicit type definition. This pins the type of your parameter in the function. This is super useful a lot of times, especially for public functions, public APIs. You want to pin the types rather than use type inference. You can, for example, if the value is detected as unused, you can replace that with the underscore. If you try to write the record, but the record doesn't exist, Ionide will tell you that maybe you should convert that to an anonymous record. However, at the same time, if something similar would exist, type X. Let me quickly create the record type. Y is something else. Let's go back here, do the normal version. If compiler thinks that this should be an instance of this type, however, it's just missing fields, it will provide with record stub. It also works for discriminated unions. It works for implementing interfaces, for implementation of abstract classes. I'm not going to show all of this right now because we don't have time. Last thing I want to show today is integration with F# Interactive. So you can just open terminal window inside Visual Studio Code. You can click plus button, open F# Interactive. This will create F# Interactive session. Let me bring that here. I don't need this. And I will open additional thing, which is called Watcher, FSI Watcher. And this is still experimental feature. Not a lot of people are using that, but let me quickly show what it does. Let's send this code to the interactive, and let's, for example, send this code to the interactive. So as you can see, this got evaluated in the F# interactive window. And now suddenly we see in this FSI Watcher tab, we see what are declared values in my interactive session and what are declared functions. This is super useful feature for interactive working with code. The performance is still not great as it's experimental feature, but yeah, it refreshes. So that would be all for me. Now I will pass the virtual microphone to Philip, and he will show some cool stuff in Visual Studio world. So yeah, take it from here, Philip.
Hello. There we go. Classic maneuver there. All right. I am in Visual Studio right now. So if you're a .NET developer, you know exactly what this is. If you're not a .NET developer, but you work in a .NET shop, like your workplace uses it, there's a pretty good chance that you're using Visual Studio and C# tooling already. And so I'm here to tell you that F# works in Visual Studio just like you would expect it, right? Let's say I want to create a new project, right? Just Control-Shift, Control-Shift-N. You can see right here, I've filtered this down to the F# language project types. I got, console app library, ASP.NET Core stuff, ASP.NET Worker Server, some test projects. You can install some custom templates in there as well. There's a lot of options there already. Another thing that's a bit more unique to F# tooling here that you may not be familiar with in the C# world is scripting. So this F# script file. So you've seen some F# script files already in the context of Ionide and VS Code. I'm going to show you a little bit of that inside of Visual Studio. So here I'm just going to paste in two functions. One is called isodd and one is called square. Isodd will take in a value and it will try to mod it on 2 and check if it's odd, and square will just square a value. A couple things I want to demonstrate before I move forward. I can do control dot. This is actually unused. I defined a function, but I'm not using it. I could just remove it if I want. Or I could move over to the parameter, hit control dot again. And I can add a type annotation, similar to what you saw in Ionide there. In fact, there is a big overlap of the features that Ionide and Visual Studio have. And so if you're familiar with editing code in one and you hop over to the other for some reason or another, you can find yourself pretty much at home. Now, of course, Visual Studio Code and Visual Studio are very different in terms of the UI and there's this big thing called Solution Explorer, and I'll get to that a little bit later. But in core F# editing, you're going to find that there's a lot of similarities, but there's also some differences, and I'll show a little bit of that as well. Let's say I want to use these functions right here. I'll define another function we'll call get odd squares. It'll be values. Well, actually, let me start off here. Let me call square, okay? I'm calling square. You can see I have a tooltip there that sort of shows me what the signature is. I hit space. Oh, I get another tooltip. But in this case, the tooltip, it's a little bit different. It highlights in bold the parameter value here. So I can see what I want to pass over to it, right? So I'm going to send these over to F# Interactive, hitting Alt-Enter. I'm going to send this guy over there, and it'll be val. It is 144. Let me zoom in. You can sort of see right there. It evaluated it. This is the F# Interactive window that's embedded into Visual Studio as well. Okay, so let's say I'm going to write this get odd squares function. I want to get a list of values, and I want to find the odd ones, and I want to square them. Okay, that's pretty easy. We'll go list.filter. I got another tooltip, except I want to call out something a little bit different with this tooltip. So it's saying that, okay, I need to pass in a predicate, a function given a t, produce a bool. But if I hover over tooltip, filter itself, the full tooltip shows that same predicate, but another parameter called list. Well, you might be asking, well, why is list missing? Well, it's not. That's intentional. It's by design. That's because we're already passing it in via this pipe operator. And so we chop off that last one in the context of piping operations, because if we were to show additional parameters, that might sort of mislead you into thinking that you need to pass in something more when you're actually already passing in everything that you need. So anyways, this is just a wonderful helper for when you're writing code. I can type my good old is odd. All right, I'm going to go list map square. I got the mapping, and we're off to the races. I'm going to send that over to F# Interactive. I will call get odd squares, and we'll pass in a list from 1 to 10. We'll evaluate that, and ta-da. All right, so from 1 to 10, the squares are 1, 9, 25, 49, and 81. That should be no surprise to anyone who understands the most basic math, which sometimes I fail at. So moving on. What I have here in Solution Explorer, so this is a script file. Script files in Visual Studio are great for just interactive experimentation, that kind of stuff. You can do more than what I showed you, but I want to show Solution Explorer. I got C# and F# mixed in here together. This is especially relevant if you want to introduce F# into an existing .NET code base. You're probably going to have a lot of C# code in there, and you're probably going to want to be able to use stuff from C# in that F# code. So here's something cool that Visual Studio lets you do. So I actually have a class right here. It defines a string. This is Philip, and it's just my name. And then I'm going to go into the F# code here. This is actually a file called httphandlers.fs. Let me zoom back out a little bit here and move this over a little bit. So this is actually a Giraffe application. You should have seen some. I don't know if there was Giraffe shown yet, but Giraffe is sort of a bit more of a low-level ASP.NET Core style web server implementation. The Saturn stuff that's part of Safe is actually built on top of this. And so you can see it's got a bunch of the wiring up ASP.NET Core stuff in there. It's got some functional routes, got some routes right here called handle get hello, get hello with name, get goodbye, blah, blah, blah. I can go to definition of one of those. All right, cool. Here we are. I got handle get hello. Instead of saying hello world from Giraffe, I want to say hello world from Philip. That Philip is defined in C#. So how am I going to do that? Well, that's fine. I don't need to mess around with anything. I don't need to build anything. I'm just going to go open C# library. And then I'm going to create a new instance of that class. Called it class 1. Very, very nice name there. I have an interpolated string here. And so instead of saying from Giraffe, I'm going to go C.Philip. And so I got IntelliSense from that C# stuff right there. If I want to see what that looks like and go to definition, it'll take me directly to the C# code that I had, which is pretty great. Speaking of go to definition, I can go to definition on stuff just like in Ionide and things that are not necessarily in my own code base, like this JSON function. Boom, this takes me to something that's defined inside a Giraffe. I can look at the option type. I can see here, I can get tooltips. I can look into this thing right here. There's a lot of experimentation that you can do just by sort of looking at APIs. And, again, this is kind of what I mentioned before. A lot of overlapping features in the F# tooling, but, some of them are a little bit different from place to place, depending on what sort of makes sense for that kind of editor. I can do find references. I can rename stuff if I like. I can do pretty much anything. And so rather than, just try to exhaustively show you everything that you can do, I'm just going to encourage you, go use Visual Studio, especially if you're a .NET developer today. Create an F# project and just start using it like you would be using C# code. And you'll find that it'll have pretty much all the features that you're looking for. And you can just be productive in it. So to wrap it up, I'm going to switch gears and take us back into VS Code. Except I'm not going to I'm not going to have Ionide loaded up here. I'm going to have .NET Interactive. So .NET Interactive, which you should have seen a little bit before, I believe, is a very cool project here. It allows you to do notebook-style programming in .NET, in this case with F#. So here, I have the square function. It produced 144, but it's a little different. So now I'll write get odd squares again. I actually have GitHub Copilot installed, so even though GitHub Copilot is not officially supporting F# right now, it can actually be pretty dang helpful. So it's able to suggest values for me there. I'm going to type in my list.filter is odd, and I'm going to do my list.map square. It knew exactly what to autocomplete for me. I'll go get odd squares. Odd squares from 1 to 10. We'll execute that. All right, cool. Got a nice tabular output here from 1, 9, 25, 49, 81. That's pretty cool. A different way to look at stuff. Speaking of looking at stuff, you can do more than just show a tabular output, though. That's if you want to do interactive programming, you got to have charts, visualizations, pretty stuff. So let's do a little bit of that. We'll call this XY, and we'll go for X in from 1 to 100, I'm going to produce a tuple of X and its square, okay? And then I'm going to pull in a charting library. So first I'll just sort of send that there. I'll bring that up. And so then I'm going to pull in some libraries here. I'll use both of them. Okay, I'm pulling in plotly.net.interactive. This is a way to embed .NET Interactive charts directly into, plotly.net charts directly into .interactive and some F# data. Just pull in those packages immediately, and I'm good to go. And so now I'm going to call the chart function chart.line, I believe is what I'm after. And we'll just send that over, and ta-da! I got a nice line chart going from 0 all the way to 100 and showing the squares there. So that's pretty cool. You can do fancier visualizations than this. In fact, I have something really cool here. This is in the Plotly docs for Python itself. Plotly is a super popular library for Python and JavaScript developers today. And so this is a continuous error bands chart. So this is basically showing a measurement and then an upper bound and a lower bound of that measurement based off of some statistical, like standard deviation, that kind of stuff. And so the code for that in Python is it pulls in some wind speed data from the wonderful state of Nebraska into a CSV and does some stuff with it and charts this kind of fancy chart. And so the question is, in 2 minutes, can I reproduce this chart in F#? Let's give it a go. So I'm going to pull in the type provider here, get some data, and I'm going to see if I can use GitHub Copilot to make this thing go nice and fast. So we'll go for row in data.rows. It's time series data, so I'm going to want the time that comes directly from the type provider. I want the X, I want the Y. All right, I don't want row.value, but instead I want the 10-minute sampled average. So then I want the upper bound. We'll call it Y upper. GitHub Copilot already suggested most of what I wanted there. It got that one slightly wrong, but that's okay. I just want to add the 10-minute standard deviation. And I want the lower bound, boom, autocomplete. I'm ready to go. So the name of the chart for this is chart.range. And we'll autocomplete that, send it off. Oh, there we go. This is looking kind of similar here. Yeah, it's okay. The color's a little off. So a few things are not quite the same. Instead of boring you with fiddling around with colors and sizing and all that kind of stuff, I'll just copy paste some code that I already had here because I'm a cheater. And there we go. This looks almost exactly like what we had. I think this actually does look pretty much exactly like the Python one. It's got the measurements. It's got the upper and lower bounds there. I think there's a few more tweaks that I could probably make to touch it up. But the answer is yes. You can do all this stuff that you could do in Python with very mature libraries in F# in .NET Interactive today. And so that about rounds out, I think, everything that we wanted to show. Went a little fast, but that's okay. I think the main thing that you can take away here is that you can do pretty much any kind of development in any development environment, and the F# tooling is going to have your back. And I think that's really wonderful because it's very mature tooling that continues to improve over time, and it's both deep and broad, which I think is great. And so, main takeaway is you can do everything that you'd like. Please try it out. Please give people feedback. And a lot of the stuff is open source. So if you're feeling like you want to get even more involved, we love contributors to all F# tooling. And yeah, that's about it.
Totally. I just want to also point out that so the language server that powers Ionide FS autocomplete, it's using language server protocol. So if you have NeoVim or Vim with LSP extensions or Emacs with LSP extensions, this, like a lot of the features that we've shown today, will work also in those editors with probably a bit more of manual setting up. But yeah, it should work just fine.
Yeah.
And totally thanks to all of our contributors for like all the projects that we've mentioned. We couldn't do that without
dozens and dozens of contributors over the years that have enabled all of this. It's not just me and Chris who are doing this kind of stuff. We just have the pleasure of being able to show off all this great work.